front of that screen. Would it be okay if you move here? Oh, yeah. Okay.
Hello?
So everybody can move to that part, and we are going to talk to empty chairs and.
Hello,
yes.
Antonio is connected.
So the guys in that part of the room. Hello? Hello?
Hello, Antonio is connected. Antonio Bobo connected. Good afternoon, everybody.
Antonio, do you hear us?
Yes. Can you hear me?
Yeah,
yes, we can hear you fine.
Can you try to speak for a while so I can make volume adjustment here in the room?
Yes, sure. So, Antonio Bobo, connected from Italy. Good afternoon, everybody. And I'm here to present the mobile
That's
use
fine.
cases.
Excellent. Thank you very
thank
much.
you.
We'll start the meeting in a minute.
Thank you. Thank you. I will mute my mic in the... Okay.
Right. So we are trying to organize a room to people to sit there. We like to speak, we love to speak to empty chairs. But you should see the speakers.
Next time I'll have assigned seating.
Okay, so folks who are now crowded, well, we still need the volunteers for note-taking and Jabber. You are taking notes, Philip, thank you. One more good soul. Yes. Somebody could to keep Philip honest. Your Jabber, thanks you have. Okay. And one more note taker. Rough notes are fine. We just need action items and very important decisions or calls for consensus. Come on. Text notes, quick test notes. Should we start pointing fingers? Okay, somebody got even that much in panic that left the room. Anyway, we'll start, and you have time to think about becoming a volunteer and helping this working group to make progress. So this is the LMAP meeting. I'm Dan Romascano.
I'm Jason Wan.
And welcome. Note well. So we are under Note well, IETF meeting. Everything that is being said, written, is according to the IPR policy of the IETF. On this slide, you have some important information about IPR and some references to the important documents. If you have any declaration, you can make it now or during the meeting or after the meeting. If you have any questions or concerns, please contact the chairs or the area director. Here is the agenda. We have one request for a change in agenda. So we have Antonio Bovo, who is remotely today, and after a certain time in the day, he has connectivity problems. He probably needs to leave the office or something. So he requested to go first. And I would like to hear the consensus of the room if there is no concern about this, because it's kind of against of our usual policy to give priority to chartered items and deal with non-chartered items after. So he's actually speaking about mobile LMAP use cases, which is the last point in the charter. It's a non-chartered item. Still, to accommodate his remote participation, we'd like to, we suggest to move him first. Any concern about this? Okay. Hearing none, Antonio will go first, but we not after we do the working group status. And we are still at note takers, so we need a second note taker. So, please, let's start the meeting.
You guys want to take notes? You want to take notes?
So Antonio is speaking. Do I start my presentation, or do you have to introduce?
Not yet, Antonio.
Oh,
Not yet.
Sorry for my sorry.
No problem.
Actually, I asked Shay to be delegated to you. So.
Okay, thank you. We have two note takers. Thanks very much. And please, by the end of the meeting, send the notes, your notes to us, and we'll compile them in 2 minutes. Okay. Status. So right now we have one RFC published, issued by this working group. 3536. We have 7536. We have 7398 contributed by IPPM. We have the LMAP framework in OAT 48. Hopefully soon, very soon to be published. And we have 3 active working group items. Of course, the important achievement between IETF 92 and IETF 93 is the fact that we reached consensus concerning the protocol and the LMAP RESTConf contribution is now a working group document. We still have an alternate proposal for protocol work, and Vic has expressed his will to kind of write a number of issues that he believes his proposal were including and that may be important. And he will look from the perspective of looking how these features can be implementing using the RESTConf proposal. He's not ready with the proposal at this IETF meeting, but he will contribute it soon to the list, I hope. We have a number of non-chartered items that are making, some of them are making actually progress. And we are encouraging, so we'll have presentation about 3 of them. We are encouraging the contributors to continue to improve their work, get feedback, discuss with the other participants in the working group. By the time when we'll have at least 2 out of the 3 current documents beyond the working group last call point, we'll start discussing about possible rechartering. But we still need to make sure that we make progress with the current charter, enough progress to make sure that the resources, the active resources, are not diluted by new work. Any questions or comments concerning the charter or the status of the working group, I should say? Okay, thank you. So we'll get first with the contribution from Antonio. So Antonio, allow me 1 minute to bring your contribution to the screen and you can go. Yes, please go ahead. Oh, no, sorry. No, that's not your one. Antonio, do you have your contribution? Did you send it? We don't have it loaded.
Yes, I have uploaded the contribution. It is at www.ietf.org/ed/draft-bovo/LMAP.
Okay, so you mean internet draft? Okay. Okay.
Yeah.
So you don't have a slide presentation. You have the internet draft. Fair enough.
Yeah, sure.
Okay.
It is version 1.
Yes, we have it on the screen. Let me close. Okay, please go ahead. We have the first page on the screen.
Yes, yes, I see it. Thank you. So, good afternoon, everybody, again. This presentation is about mobile LMAP use cases. The idea for mobile LMAP use cases, according to the last meeting, is to put in place a number of use cases that have some specific points related to the mobile domain, so that can be complementary to the landline networks use cases, and so it could be interesting in characterizing together with the landline measurements to have a better frame measurement frameworks. So let's move a little bit down the document, please. So.
Okay, so let me know what page you want to get. So I'm on the table of contents now.
After the table of contents, please to the introduction, section 1. So we all know that networks and services are experiencing an exponential growth of mobile traffic. So this traffic is introducing additional situation to specific for mobile, and this is exactly what we have in mind to complement the current LMAP with some specific about mobile. This document is organized with a table that is summarizing a number of examples of use cases, and after that there is some specific description about these use cases. The list is not exhaustive, but the intent is to give some examples that can clarify what we have thought about such characterization. This presentation is the outcome of the work done by all the members of the IEEE group that have worked together to put in place this draft document. Let's move a little bit down to section 3, please. Okay. What is behind the mobile broadband measurement use cases? There are basically 4 major topics that we have in mind. So basically, mobility is one of the primary reasons for variation of a service experience over time. So mobility is distinctive of the mobile domain, as we all know, and there are several use cases that can take advantage of mobility characterization in understanding what is the real end user experience. But mobile networks are affected also by radio conditions that impact services, for sure. But not only radio conditions are important, but the variance of radio condition is faster than the landline networks. So these 2 aspects, so the presence of radio condition that impact services, but also the variation of link condition due to this situation that is faster than the landline networks is, in our opinion, important to be characterized. And last but not least, roaming scenarios and multiple operators are specific of mobile domain. Roaming scenarios, we all know what is behind this. But even multiple operators with the scenario of shared networks could be something that is important to notice, because access network can be shared between multiple core network operators, so it could be interesting understanding if the resources are used properly as expected. So let's move a little bit down to section 4. So here there is a table with a number of measurement purposes of measurement application. The reason for this table is a little bit more clear if we comment directly the use case list. So go for a moment a little bit to section 5 behind. Section 5 use cases. Exactly. So section 5 is a table with on the left a number of examples of use cases. In the middle there are the stakeholders that can take advantage to characterize such or to solve, to manage such use cases. And on the right, there are some measurement purposes or measurement application that can be used to manage such use cases. For example, to make an example, service check is important for individual enterprise users, but even for virtual network operators. And there can be some measurement application that can be, for example, assess the network quality, or understand if there are problems of coverage or something like that, that can be useful in understanding how much the service is is giving a good quality to the end users, individual or enterprise. So the number on the right refer exactly to the list of measurement applications that are in the table above. So if you move above a little bit to the previous table, we can see that the numbers are exactly referring to this list of measurement purposes of end application. So the intention is to give a synthetic view of use cases, stakeholders, and application that can be useful for these use cases.
So
say that,
Antonio, obviously
yeah,
we do not have time to go now through all the use cases. So maybe first of all, I would like to ask the people in the room who has read this internet draft. Okay, so it looks like nobody has read in the room the internet draft, which is kind of not very surprising, because it was a late submission, and people were. So if you can maybe just take one example, because people need to read before they provide feedback and opinions about how useful it is, how obvious it is, how they understand. So maybe one example would help, and then we'll defer the discussion to the list for more feedback after people have some time to read.
Yeah. So if you move down to the first example, section 6, in the next session there are all the use cases with the description and the description of the use case itself and the application that can be useful. Service check is one example that is very obvious to understanding how the service quality is characterized, considering even the location, even the mobility, even for example, the cell, for example, the type of radio interface, for example, which operator is managing the service. And all these dimensions are useful to characterize in the proper way the service. And for example, mobility and radio condition for sure affect the service delivery. And the application that can be useful to do such characterization are correlating the measurement to the location, the measurement to the cell, but even to the geolocation, and to understand if there can be impacts, for example, due to shared networks. Only 30 seconds to another example that can be useful. Move down a little bit to section 7, and perhaps I've used all my time. But section 7 is for cellular tower operator. Cellular tower operator can be interested in, as stakeholders, in understanding how well the network is performing, to understand if there is the need for additional sites. So there is the need to have more coverage. There is a need to have additional deployment of antennas in the field, because the cellular tower operator can be different from the core network operator, and at the same time it can take advantage of these measurements to get a more proactive behavior, so understanding how the network is performing and give suggestions to core network operator to configure differently the network, to take advantage of the experience of the cell tower operator, to improve the interoperability of the access network and core network in order to achieve better services. And this type of measurements can be exactly useful for that. But there are also other use cases, for example, comparison between different UEs, different devices that are in the same geographical location, to understand and to characterize how well the mobile UE is performing under a certain area. So thank you very much.
Yeah.
There are, yeah.
So thank you. I believe that we need to cut here because we are kind of running out of time allocated for the presentation. And thank you for bringing. I will say a few words before, and if other people have also comments. I happen to know a little bit more about this work, because this is actually quite good shape from a format and from a concept point of view, because it's a result of a study group which ran in IEEE 802.16. They didn't conclude with any, correct me if I'm mistaken, Antonio, but they didn't conclude with any standards work in 802.16, but they decided actually to provide and release the content or part of the content to other organizations, and possibly LMAP. The LMAP working group is an organization that seems fit. Having said this, and also appreciating the quality of the work here, which is, I would say, beyond our average draft 00 contribution, I should also say that we need, and I recommend to you also, Antonio, to look at our use cases document and framework document, because there may be, for example, a need to revisit some of, for example, the use cases that we have taken into account include the internet service provider and the regulator, which it seems to is that your service provider is not necessarily an internet service provider, at least to the extent of what you are defining in section 7. So there may be a need to extend the framework, or to rephrase or give up to some of the use cases, to part of the use cases that you are presenting. So there needs to be some discussion on this aspect. And of course, I invite again all the participants in the working group. So this is future work, possible subject for as one of the items in rechartering, and it needs review and discussion on the list. Are there any other comments in the room or questions? Okay, hearing none. Thanks, Antonio, and please continue to contribute, and you are invited also to participate in the work of the other items that are currently in the charter. We'd appreciate your input.
Thank you very much to everybody for your attention. Thank you.
Thank you. Okay, Jürgen. Wow, does it come this? No, I didn't do this. Oops. I overcame the... Okay. Let me see if I have it here. 1 moment. I may have it here. No, this must have been yours. Yeah. Oops. Sorry for this.
So we're going to discuss information model, I guess. So who has read the last version of the document? Okay, cool. So here we go. Short summary of the changes since the version that we had at the last IETF. There was a request that a task should be able to refer to multiple entries in the registry. The reason was that you might have a task that sends out one packet train, but actually the traffic train calculates multiple different metrics. And so we have turned that leaf into a leafless. Second bullet item, consistent usage of the term action and task. So last time when I updated the document, I was kind of focusing on getting all the object definitions and descriptions right, and I didn't focus so much about the surrounding text. And this time I focused on the surrounding text to get it in line again. So I hope I got it in a better shape. Third bullet item, schedules are triggered by events instead of timings. Timings are just one of many possible event sources. That goes back to the presentation we had at the last IETF from IEEE people that said we might have other events that are not timing events, like if you enter a certain network or a certain network interface becomes available, or you enter a certain geographic location, you want to trigger certain tests. And so in order to make this easier to plug in into the future and still be meaningful, essentially the top level container has been changed to be called an event, and below that we have timing objects that give you timing events, but there might be additional event types in the future. Actions feed into schedules instead of actions within other schedules. In the previous version, a task that was kicked off by a schedule could say, well, the output of this task, or actually one of the outputs of this task, goes into task number 7 in a different schedule. This complicates matters quite a bit. And in order to simplify this, the restriction is now that you can only send to another schedule, which in most use cases is exactly what you want. If you have a use case where you have more complex constructions, you would have to split this up into multiple schedules. But I believe it's optimizing for the common use case and significantly reducing complexity. And because of that, we also removed the notion of multiple task outputs. So a task has essentially one output, but data that is being produced might be tagged. And so the idea is that you can filter on the tags in case you're only interested in a sort of subset of the output produced by a task. Last bullet, the tasks or the actions that are part of a schedule can be executed in different ways. So they can be either kicked all together, that's the parallel mode, or they execute sequentially. So you run one task, when it's complete, you kick off the next one in the sequence. Or you can execute them in a pipeline mode, where you essentially pass the output produced by the first task to the input of the next task. And again, that makes common use cases simpler and avoids the complexity of having to distinguish multiple task outputs and to wire them into different places in other schedules. Next slide, slide 3. Yeah, while reviewing some of the comments that came up, I stumbled across this term instruction task that is somewhere used in the document, and we had a discussion on the mailing list. My conclusion of that discussion is that the term isn't strictly needed, and we should better get rid of it. I don't know, Tim, do you have an opinion on that? Or?
Tim Carey, ALU. So yeah, I mean, instruction task was meant for the collection of schedules and actions and whatever that would all go down in a bulk that dealt with how do I get this blob to execute, right? And so if we're saying that now we're not really worried about that logical concept, which I never, you know, in the data models for BBF, I never really worried about it anyway. We didn't have the, it was an artificial construct. So I have no issue with removing the construct from the information model because it was artificial for us.
Yeah, so the background was we were looking for terms on how to distinguish tasks that do measurements from tasks that do infrastructure work. And while searching for the right term for these kind of things, we ended up finding this one and found that that is really confusing. Okay, so we're going to get rid of this. Next slide, slide 4. Need to describe if scheduled tasks or scheduled actions are to be disabled.
So, Jürgen, just procedural question. Do you believe that we had enough discussion visibility on the list to decide that we are getting rid? Or do we need any consensus call for this? Or we can estimate consensus at the time when we go to last call.
Yeah, I think that's probably sufficient because it's not a major thing. It is a little wording thing. So if we make it inconsistent, I believe people will flag it during last call.
Okay.
Okay, that was Tim's request, and I think it was related to the loss of connectivity to the controller. And if schedules get disabled, so there was the question of what gets exactly disabled, and I think we settled on the schedule gets disabled, and so implicitly all the actions that it would kick. And there was a discussion how are they re-enabled, and I think there is text in the current version that explains that how it's supposed to work. You're not convinced?
So I just read the draft because it just came out, you know, what, a couple of weeks ago, and then I read it a week after before this. So I wasn't convinced that we've got it down yet. So I was going to look at it again, because I have to take the 06 version and rev the TR69 model for it, right? And then I was going to go look and do what I did before, was just start taking action points and putting it to the mail list. But it looked like when we talked about it, there's a fundamental problem of an operational status of an entity, whether it's a scheduled task or whatever, versus the administrative state, and we don't accurately reflect those statuses and states within the information model. We don't separate those, so I don't know if something's been errored or not. Yeah. Oh, well, there you go. I think they're all kind of bound together, though, right?
Yeah. So the current version of the information model provides status about configured tasks, but not about schedules and actions. And they are actually more important, and I agree with you. Right? You want to know which schedules have been disabled. You want to know what the state of various actions is. You want to know what the overall state of the agent is. So I agree we need to add that state into there. But yeah, I would like to ask you to look at the text that goes to the first bullet and double check whether the text is good enough. Yeah, I'll do it. That would be right. Yeah, great. So I think we've covered this slide. Next slide. Open issues. Yeah, execution mode. So execution mode is if you have a set of actions in a schedule, whether you run them parallel, sequentially, or in a pipeline mode. At the moment, we don't have a default for that. And I think it would be useful to have a default, but then the question is, what would be the default to have? I personally think it should be either sequential or pipeline, but I'm open to suggestions.
Yeah, this Tim Carey, I would agree that it would either be sequential or pipeline, and I would think our initial intent would be pipeline, but I do have a larger. Huh?
That would also be mine initially.
Yeah, I do have a larger concern though that I need to express when we're done with this about the information model piece. But for this particular one, if I had to, as I read the draft, and you were asking for a default, I would have picked pipeline.
Okay, good. Any other opinions? Okay, then I like to go with pipeline. Second bullet, is the current handling of lost connectivity sufficient? So that goes back to the previous one. That's the same one. There should be status objects for schedules and actions. Yeah, that goes back to the previous one. So I agree. That's just acknowledged. I'm sorry, we'll try to come up with something that addresses this, and then send it to the list, and then you can look at it. Yeah. Slide, next slide, if there's any. Okay, so Tim.
So if you can go back to your first slide. So when I looked at this and I did a compare between 05 and 06 of the information model, you actually, you've got all the pieces obviously, right? But I was a bit concerned that we're making changes to the draft, and again, I'm marking to the draft, right? We're making the changes to the draft that aren't necessarily been discussed before. Particularly, I'm not sure, and we've had discussions on like how to do the task outputs and that stuff for, numerous times, right? And I thought we settled on it, and then when I looked at the 06 draft, and it's got something different again. And so when we talked about the notions of actions feeding into schedules and the removal of the notion of multiple task outputs and the support for sequential, and then all of a sudden the action for the sequential pipeline or whatever, I was like going, when did we discuss this? And maybe I missed the point. And was it ever taken to the list before it was put into the draft? Because again, I'm taking my data model from the information model, right? And when you make changes, and we haven't really discussed it, right? We really don't know the different we don't know the different viewpoints of the different data models they're out there. It seems like we're just taking the viewpoint from the data model that's being done through Yang, in that case, to make it maybe Yang easier or something. And I say the same thing with renaming of stuff as well. As I was going through there, it's kind of easy for me to rename stuff, but it's just I would like to have a more open dialogue before we change an information model based upon just one of the data models.
I think the issues have been brought up before on the list, but I would have to go back and dig into it to
Oh, then I must have missed them. And if it is, I apologize. I looked at it and go, I don't remember talking about this.
Yeah, one other thing that happened in the last cycle is that we decided not to have a second interim. And the fact that we didn't have the second interim actually caused the fact that version between 5 and 6 actually, it was kind of Jürgen and the team looking at the information model, kind of trying to figure out what needs to be changed. So maybe there was less discussions that we used to be, because if we had an interim, probably these changes would have been brought up.
Yeah, and the only thing that I just ask is, again, and if I missed it, I apologize, but let's just make sure that before we make any changes to the drafts for the information models, we at least get it onto the list, because the organizations that are doing the data models may have some input as to.
Now this being said, I also should say that this is a mode of work that we decided about. So we decided that we develop in parallel. We don't serialize the work. So it is kind of a part of the process that we agreed about to feed back some of the practical things that we discover while doing the Yang model back into the information model.
Right, but if we can take them to the list to have that discussion before we put it into that, I'm okay. I'm okay with it. In fact, it goes quicker, right? Because if we can get to the thing, then I don't have to come back and go through the thing and then make the comments afterwards, which makes it more difficult to change, right? We're talking about a common information model that two organizations are deriving data models from. Right, and one organization is saying I need to change the information model based upon my derivation of either my protocol or my data model, and I'm like, okay, let's talk about that and make sure that you don't break the other one before you document it. That's all I was getting at. And so as to the task, that was the only one that kind of really threw me. I couldn't understand why the task now is built for multiple registries. A registry entry was supposed to be a test that was going to be executed, right? And a task was associated with the test. Why do we now have a task being associated with multiple tests when I use actions to feed into other stuff?
So there was a message from Al Morton to the LMAP list. And my understanding of the metric is that it defines a metric and not a test in that sense. So it defines a metric, and he said you can send a traffic pattern out to actually calculate multiple metrics from it. And so if you have a task that sends this packet train out and calculates multiple metrics, then it should actually be able to refer to multiple metrics in the registry.
And in this case, the metrics, one way of measuring the metric wouldn't feed into, you wouldn't measure one metric first and then feed into the next metric for the actions and stuff, or sequentially do the metrics tests. I mean, I'm just trying to understand. Now we've got multiple aspects there, and then we have of what does a device do if it has multiple registry entries, multiple metrics? Is it still going to execute one test, or I guess that's what I'm missing.
The task can declare that it's measuring multiple metrics. Right? When you kick off this task, it's actually not just calculating one metric, it's calculating multiple.
But that registry entry in IPPM has inputs, outputs, conditions, and a whole bit, right? And so if I'm a CPE that gets multiple task entries in the registry, there he is.
Mr. Registry.
Hi, I'm Al Morton, and I know what I want. So in the world of measurements today, we don't have a registry today. Here's what we have. We have a specification for a stream of packets, and in the active measurement world, we launch that stream ourselves, and then we measure metrics on that stream. And we don't usually just measure one metric. We measure loss, delay variation, and so forth. What we want is to measure multiple metrics on the same stream. And that's the flexibility that I believe Jürgen and his colleagues have added to the draft now. And that's very valuable because it's very economic. We certainly don't want to launch 5 parallel streams in order to each measure one metric on that stream. And this is the way we've been doing it for years, and I think this is finally some reconciliation between the way tasks work and the way the metric registry works. The metric registry is new, and the way we decide to define that is with a full combinatorial set of things in the registry. So basically everything has to be specified, including a single metric at the end, a single output result. So now when you see a set of registry entries and they all have the same stream characteristics, the same input characteristics, then the obvious interpretation is that, and a single task, a task can reference multiple registry entries. Then what needs to be taken from that is that there's going to be one stream with one set of registry entries, one set of metrics registered on that single stream, measured on that single stream. Does that make sense?
Yes, but in the registry itself, there are attributions for things like inputs, outputs, conditions.
Yeah.
And so the question that I had was, okay, how do all those if I set up a task that have multiple registry entries that have a set, each one has its inputs, outputs, what it outputs to, how does a CPE know, is it just a union? Is the inputs and outputs and the conditions a union for that stream, for that test? So the properties of all the metrics together become a union that you run the test against?
Yeah.
And that's okay. If we can make that clarification, I would be good. I was trying to figure out, how does a CPE align all the inputs and outputs? So I do an input here, output there, and another input and an output. How do I string the metrics together?
I think, Tim, that they have to be unionable. That's not a real word, but you know what I mean. You have to be able to combine them in a way that makes sense. If the registry entries referenced different stream characteristics for their basis, then those would not be combinable.
Yes, but they would be in different tasks.
They should be in different tasks. That's right.
So then guidance would be from the registry drafts that talks about metrics that would be combined as a stream or task. What you're dealing with should treat the sets of properties, the inputs and outputs, as a unionable.
Yeah.
Okay, and I'm okay now. I'm fine because now I know how to handle it. Right?
Yeah. Okay.
Now let us see if Philip is okay.
Philip Hurdley.
Yes.
So does this mean that in the registry we have to have some way of knowing that this kind of set of registry entries all has the same measurement method? It all has exactly the same fixed parameters? And
I think that association comes from the task assignment here. In other words, they would all have the same stream characteristics and a different metric or even a statistic at the end. and for the registry entries, right? So 5 registry entries, they all use the same stream characteristics. It's completely redundant. But they have different metrics as a result. And if they're all specified in the same task, then they're all based on the same stream.
And how easy is it to know that? Because you'd have to go and, as a CPE, you wouldn't know that ahead without having looked, well, unless you have to kind of look through each of these different, the 10 different tasks that you've been given, and then somehow go through and find out that, yes, in fact, they're all exactly the same when it comes down to what active traffic you're sending on the wire. That kind of sounds much harder thing to do than for a simple CPE, whereas they were supposed to be just, kind of doing something trivial, the CPE, because it might be low power.
Well, the CPE has to understand the registry entries by their index number or name in advance.
Yeah, but it doesn't know that that registry entry 1, 99, and 120 all in fact potentially are exactly the same traffic on the wire.
If the traffic stream is completely specified in the registry entry, then they would.
But they've got to do quite a lot of work to find that out, because they've got to go and look in the registry entry, look at that, or compare that one. Oh, right, they're the same. We need a way. I totally agree with your requirement, but we've got to find a way in which, I don't know, we have 2 stages of registry entry that indicate.
Well, if there's something to do in the registry, I think we should do it. But let's think about that.
But again, I mean, a CPE is going to say which of the metrics or the registry entries that they provide capabilities for. So if we use this as an example of ping, where I can get round trip, or I can get round trip delay, or I can get round trip time, or and average latency, or maybe a metric, 2 different metrics. Example, I'm going to have 2 registry entries potentially for that, right? Because it's got 2 metrics that you want to count, and both of those would have to be into a ping task, right? And then I'd have to be able to sort out what inputs, and I'd have to create a set of inputs and a set of outputs that would be unique across all those tasks, and then have the final metrics that get reported out, right? To include also if there's any output downstream tasks that they wanted to deal with, as well as conditions, right? And that's what we're saying. So it's still ping is the stream. I might want to test round trip, and I might want to test delay or something like that, right? Whatever metric you define. Is that accurate?
I think so.
And so I don't see, Phil, that there's anything that we really need to know more. So I'm kind of missing where your concern is. And he's not listening.
He's taking that.
So I think we have it just by right now by doing it. But if there's then I think it's incumbent upon the registry to kind of define, the interrelationships between metrics now, right? That would be a part of a task.
It seems to me like this text needs still to be worked out and discussed on the list.
So one question to the IPPM people: how stable is the metric work in IPPM, the registry work?
Yeah.
It's just gone to working group last call, so we may make a few comments on it.
It would be very useful to forward the working group last call to LMAP, I would say.
Right. So can you send one more message to the LMAP list to remind people? Yeah. Yeah.
Sorry, to be accurate, it's not in last call, but I think on the Friday, is it Friday the meeting? The intention was to ask, should it go to working group last call?
Yeah,
okay, so when it goes to working group last call, please cross. Yeah. Shamelessly cross. post on the LMAP list.
You could also raise this at the meeting on Friday. This specific issue while people are all here together to
yeah, this is a
chat about it.
dependency that we knew from the beginning that actually we decided not to undertake any registry work and to delegate it to IPPM.
Yeah, but I'm just saying you don't have to wait for it to go to a blast call because it sounds like a fairly substantial.
Well, it's not a long wait
change
because
to the
it's kind
registry.
of this Friday.
Yeah.
Which is tomorrow, which happens to be tomorrow, yeah. It's Thursday. Oh, thanks God, it's Thursday. Good news. Okay. Anything else on this? Then next is Jürgen with LMAP. Measurement Agency, Young.
So I know the pain of keeping two documents consistent.
Young model.
Okay, Yang, go to the second page. Again, the changes are kind of similar to the information model changes. So essentially, that's just the same done to the Yang data model. Yeah, go to the third slide.
Any comments here?
Next slide.
Oh.
Yeah, Vibe, he asked a question. The granularity of the periodic timer is in milliseconds, and whether that's really useful, and whether seconds would be reasonable to have as the smallest granularity. So that's the timer in which you can kick off schedules, right? And so the question is whether that is meaningful to do in a sub-second granularity.
Tim Carey. So, we've used milliseconds in the BBF for diagnostics, particularly for repeating intervals. So you can imagine that you do a ping and you want to do that 3 times in a row and you get the first one back in, 10 milliseconds or 12 milliseconds, and then you get the next one back in 30 milliseconds and you get the next one back. And you see what I'm saying? So you actually can be sub-second. Oh, I'm sorry. So we use in general our general scale for time is milliseconds in the BBS for diagnostics, and the reason is that you can do repetitive diagnostics that are sub-second. Ping is an example. I might want to send out 3 iterations of a ping, right? I might have to go execute that 3 times. Right, and so you do those repetitions. Your first one might come back in 20 milliseconds, the next one 200 milliseconds, the next one 500 milliseconds. That's all sub-second, right? So that you're dealing with. So
anybody has a different opinion?
So you're triggering a task to send one ICMP packet, so you have to trigger tasks at high frequency to send 3 ping packets?
Well, that's an implementation thing. We talk about it as terms of iterations, right? So I might send 3 pings, so 3 ICMP packets, right? One after another. We call them iterations, and the iterations are timed as milliseconds. All I was saying was that in the BBF, we've just settled on the milliseconds as being the lowest granularity for those type of reasons.
Joachim Fabini, perhaps a remark. It might be interesting to use milliseconds because you have time-slotted networks that operate time synchronous, and starting at the milliseconds order might be interesting to avoid such conflicts with periodic behavior of networks.
Okay.
You are anticipating 2020 when the whole internet will work at 1 millisecond end-to-end delay. That's what I'm hearing. Okay, so we stay with milliseconds. It looks like.
Okay, good. The other things are more homework for myself. Of course, terminology should be consistent. And so. Next slide. The open issues listed in the document are task option groupings. That's a Yang issue. So a task can take a list of options. And Yang requires, if you model this as a list, that you give every option a unique key, because we want to have options to be able to be present multiple times with the same name. That's a little bit ugly, but I haven't found really a good solution other than providing this artificial key. Unless someone has a better solution for this, I will probably put the kind of ugly solution in place. The second bullet is more fundamental. The Yang document actually has two data models inside. One is for configuration and instructions, how LMAP people would call it. And the other data model is for reporting. And it's written as a data model. However, no, it's written as using notifications. So the idea is you run a REST-conf server on the CPE and it ships results as notifications to a notification receiver. Now, if you do this over HTTP, you need to have essentially an open connection, or you need to set up a connection and call home. And then you have essentially a hanging request from the receiver coming, and then you push the data over that hanging request, which is kind of doable, but not very pretty. And it's not what typical implementations do today. So typical implementation that I've seen actually do a REST request to a collector and just deliver the data. So I think we should change that to something that matches more what implementations do today, just making a REST call. What the slide says, there might be a way of modeling, well, just flipping the roles. So you have a server on the collector, and essentially the CPE becomes a netconf client, and then does a call to the collector to deliver the data. There are two ways of doing this. One is modeling, having a data model, and you use the REST-conf capabilities to send data into that data model, which, however, leads to some interesting interpretation of how Yang works, because usually you mark something as config true data to be writable, but we are not really writing config in that sense. Right? We are producing results that we stream into something that finally goes into some internal database, but is not becoming part of the configuration of that server. So I did send an email to the Yang doctors list the other day to check what they think about it, and someone said, well, why do you not model this as RPCs? And I think that's actually a decent suggestion. So what we could do is have a data model such that the REST-conf server on the collector just exposes some RPCs that essentially allow you to deliver the data. So what it boils down to is exactly the same on the wire. You have a post going to the collector and ship the data. It's the way you write down the Yang mechanics to do it. But I think it's the cleanest solution to this. Have I been too fast? Has everybody understood what I'm talking about? Questions, comments?
So Tim Carey, I will say what we've done in the past is we relied on other transfer protocols like HTTP file transfer and FTP to do the file transfer mechanisms, right? We can still do it in band, but we have these other elements. And we do configuration to allow to set up these profiles, and basically the collector is essentially a profile on how you do the exchange. I think what you're suggesting is that this REST-conf server would be a collector profile, right? That you would deal with, that would be REST-conf itself, right? And you wouldn't allow for maybe an exchange using HTTP or FTP or whatever, just using REST-conf. Is that accurate?
Yes, but REST-conf is essentially running over HTTP, and so it's using HTTP.
Yeah, we found that, like, for large results, the actual file transfer is more efficient, right? You know, for that, instead of doing the in-band elements. Just found it, because you can compress it, you can encrypt it, you know, or whatever, you know, or you can compress it and it works just fine. So we just found it to be more for large data sets, it was found to be other file transfer mechanisms found to be more efficient. So we allow for multiple ones. We kind of abstract it out and just say collector's got a profile, supports these this protocol, this exchange mechanism, and we assign that profile to the reporting aspect of it, and just say use this profile when you want to report the stuff up to the collector. And so we allow for collectors to be, in our case, an ACS, which is the TR69 server, or it can be an HTTP server or an FTP server. But we try to keep that options in place for the flexibility.
Yeah. Well, the IETF has a tendency to try to converge on one solution to maximize the chance of it works together.
Certainly a server is a better approach than everything.
Yeah.
So this is right now, you initiated a discussion on the NetConf mail list. And your question was the way I read this is kind of this may seem a little bit odd from the NetConf perspective, but you really see any problems.
So what we have now,
do you expect anybody to detect any problems with this approach? Because that's how I understood your question on the NetConf list.
What do you mean with this approach?
Sorry, what the use of NetConf, the way NetConf is being used.
So, again, the current draft says the RESTConf server on the CPE sends results as notifications to the collector, which is a RESTConf client.
Right.
Over RESTConf, this means the client has to do an HTTP request on the server, which then has an event stream inside of the response.
Right.
What typical implementations do is that they do a call from the CPE towards the collector to deliver data. And the corresponding model in the RESTConf world would be that you have the RESTConf server on the collector and the RESTConf client on the CPE. And then you have two options. Either you expose writable config data and you populate the config data store, even though it's not really config. Or you have the option that you have declared RPCs on the collector and you just use those RPCs, but they don't really go in the data store. And that seems to be a cleaner solution.
Okay.
In terms of bits on the wire, the difference is hardly visible. So my feeling is, in order to be closer to what existing implementations do, I like the idea of putting the RESTConf server on the collector.
Okay.
But the only downside is that you need to provision, of course, the security credentials, because the RESTConf client on the CPE needs to be able to authenticate against the collector.
In order to enter the session, yeah.
But if you do that, that shouldn't. Is there anything that we're not going to have to change the information model for that because it's just all data model stuff, right?
Yeah.
Yeah.
Okay.
You're safe.
Just thank you. Otherwise, we'd have to do some abstraction.
Okay.
So real quick, just go back to what Tim was concerned before. Do you expect any changes coming from the Yang model to affect the information model at this point, or are we pretty solid?
I think we're in reasonable good shape. So I don't expect. So definitely not from this reporting. I think that's really a way of how we interpret the information model in the Yang RESTConf world. I don't think that goes back and causing changes in the information model.
So what's left to be done with the data model?
Well, we have to settle what we want to do. So do we want to move the RESTConf server role to the collector? And then we have to work out the details. So it's essentially the reporting part that needs work. The other part needs, well, cleanup work, but nothing major at this point in time.
Okay. Now the reporting part is in the same document, right?
It's
right
currently in the
right
same
now
document.
we have one document,
Yeah.
and it's a plan to keep it as one document.
Could be split, could be, I don't know.
Do we anticipate in the future kind of a separate evolution? Because that would kind of modularity would be useful in any way, or just overhead?
So there are two questions here. Either it's you complete them at different times, that would be a reason
Yeah.
to split. Otherwise, there's not really a reason to split because you can always take portion out and replace it. I mean, you can just obsolete a portion of something and replace it by something else. It's not as thin, but it's possible.
Yeah, but then you know, you discover something that is specific problem only in the collector, or a new way to do configuration, and now you need to change the whole RFC. I don't know. I'm asking. The document is not huge, so okay. So we are happy with one. Okay. Timeline for the next iteration.
I would say September.
Okay, we'll talk about this. So September is kind of the middle. The IETF meeting is first week of November, very first week of November. So we probably have time, if we decide for an interim meeting, we have time only for one. So we should talk about something target like mid-September.
I mean, you mean a physical or virtual?
No, I mean a virtual. Unless, I don't know, BBF meets again in a nice place. That's too early in September, I guess. Oh, so we go from Guinness to Port. But the date is not really good because with all the vacation time, and I don't believe that there is time for an iteration between now and. So we'll try to target, but we'll talk about this at the end. But okay, okay. So one moment, and Jürgen is next.
Yeah, very efficient. Yeah, but the good news, this document didn't really change content-wise, so it changed its name. It got aligned to the data model changes so that the examples in there should be consistent with the current version of the data model. But that's essentially it. Next slide. Vibe asked some questions. So there's this appendix that has this protocol comparison thing. Should that be kept or should we move it out? You say yes, move it out.
As a contributor, I know. Anybody believes that the protocol comparison, which is actually kind of a justification why RESTconf needs to stay in?
Okay. And the rest ones are more, clarified better how the example exchanges are to be understood, but we have to redo them anyway if we move the RESTconf server role to the collector. And yeah, so that's more editorial homework for myself. Terminology editorial, that's so nothing that is in any way substantial.
Okay, so before we go, because the next items are now feature work, so we're kind of concluding our charter work part. So now I'm asking, because you are a principal contributor, so you have help on some of the documents, but is first half of September a realistic time for updates, and try to look on the calendar about how second half of September looks from a possible dates point of view for a virtual interim.
I would feel more comfortable if it would be second half of September for an update and beginning of October for an interview. So I'm going to be gone in August for a couple of weeks. On
the famous European vacations.
I apologize.
No, you don't need to. Enjoy. Okay. So first half, but we shouldn't go too late because actually I would say last week of September and first week of October for the interim, because again, actually we can try to look. We have this wonderful tool. What is he done?
This is how these wonderful tools sometimes are.
Yeah. Why is he downloading a proxy script for? Okay.
So the draft deadline is October 19. That's what you were looking for.
October 19 is a cutoff?
Yeah.
Okay, so October 19 being the cutoff, we should probably have, is this a Monday?
Yes, per usual.
Okay, so we should probably have October 12, so we should have like October 5, so it should be the last week. So we should try to do either the week of September 28 or the week of October 5 for an interim. So to leave time for 1 week at least for spin-offs after the interim. Anybody knows about big obstacles to having a meeting in the week of September 28 or the week of October 5? Any conflicting meetings or stuff? David is looking on his take. No? Okay. Okay, so we'll launch the usual doodle. And this means that internet drafts, please, until September 25 or something like this.
Okay.
Okay, thank you. Okay, so now we have a number of contributions on future work. Again, rules of engagement. This is work that we encourage people to do on the individual submission, discuss, get feedback, improve. And if we are in good shape, sometime later in the year, we can start discussing about rechartering, but it's too early now. So first one is collaborative LMAP.
Hello? Is that okay? Okay. Hi, everyone. I'm Rachel Huang from Huawei. In the last IETF meeting, I presented this topic, and I believe the consensus was to focus on the use case. And this time, I'm going to just focus on the use cases. Yes, please. First of all, let's have a brief recap of what collaborative LMAP is. Collaborative LMAP refers to the scenario where multiple autonomous measurement systems collaborate together to perform large-scale performance measurement. And currently, it is not in the scope of LMAP because current LMAP just assumes only one controller. Our expectation is that the collaborative LMAP could be considered in the next stage of working group. Next, please. Next. We considered use cases from 3 aspects. The first category of use cases is from regulators. Regulators may have the requirement to monitor the status of overall network. Regulators usually do not deploy their own probes. Instead, they rely on current situation of its regional networks. It relies on existing deployed LMAP systems from different ISPs or different third-party companies. And these different LMAP systems need to collaborate together to perform large-scale performance measurements to give a whole picture of the network status of a very large geographic area, such as like a whole country. Regulators may also have the requirements to monitor the status of the interconnection of different ISPs to promote network development. To understand the interconnection performance could help regulators to formulate policies to promote information sharing between ISP networks. In addition, regulators in different countries may also have
Okay. So we need to do this. There you
Second slide, please.
I need to do a resizing.
So the problem is basically, how do we quantify the right amount of router buffer sizes that we need today in the WAN? It's a huge problem, but the scope of this is just limited to outward-facing links that suffer latencies from 40 milliseconds to 150 milliseconds. And why do we need that? This is a very old problem and it's been confused a lot with buffer bloat, delay, jitter, TCP congestion issues, and everything. While they are correlated, the scope of this is pretty much related to what it is from an ISP's point of view. So, in addition to other advantages like having considerations between SRAMs and DRAMs and power consumption and size in the board, you're also going to want to drive down the cost of dollars, per gigabit, which is the single most metric we use when designing the WANs or the data centers in our networks. And one of the ways to do this is to be able to mine the data from an operator's network. We have petabytes and petabytes of data which we mine regularly, but what is the data that we need to mine and how do we analyze this and just bring this down to small kilobytes of data that will tell us probably through a graph, what are the metrics we need and how can we just quantify the buffer size. Next slide, please. The rule of thumb so far has generally been the right buffer size that you need is the round trip times multiplied by the capacity of the link. Traditionally, most vendors define their sizes based on this formula, which is, let's say you have a 40 gigabytes link in which suffering from a 250 milliseconds latency, you will have a buffer size of about 10 gigabits. And that is a lot of buffer. Our empirical data, and I'll show you some slides later on that, we don't need that much buffer size. But however, studies have shown, and people at Stanford, especially Guido Appenzeller, Nick McQueen, all these people have shown that that is quite not true. And that holds true for maybe a single TCP flow based on the sawtooth waveform and the AIMD characteristics. But if you add a lot more TCP flows, it doesn't hold true. And so they came up with this new formula, which is divide that by a number of, by the square root of the number of concurrent flows, which also works. But what we have seen from our empirical data is that that's not really true. So the problem remains as to how do we quantify the router buffer sizes. Next slide, please. So most of this work that has been done is theoretical in nature. It's for a small number of routers in a very small network that does not mimic an operator's network by any sense. It's for a short number of flows. I think it was about 300 flows or something. And we have a lot more flows going on in our networks. And it was based on, they ignored the short flows and they focused on the long flows. But we have seen that short flows also considerably affect the study. And we've seen that it doesn't matter. You could have small buffers in transatlantic or trans-Pacific links with lower link utilization, and you still have packet discards. So you have, and it's not based on some kind of router misconfiguration, or you're having packet discards, and there's no real known reason as to why they're happening. So there is need for new work. Next slide, please.
So the reason that I brought this up to the LMAP is, there is a lack of having, and this is the question that came up in the previous presentation. There is no collaborative work happening between providers where there is a way to understand, hey, what are the metrics that we need, and how do we use these metrics in a big network, and have some kind of a platform to analyze this. And there's also a lack of a way to basically represent those petabytes of data in a clear and concise fashion. Next slide, please. There's a lot of data that we need to study the router buffer sizes, and these are listed in the draft, along with an informational model that we've used recently. We have a bunch of read and write parameters. One of them is simply to have a trial method to reduce the buffer size to see what's the impact on the number of flows and the discards. And all of these details are present in the draft. So we'll move on to the next slide. So this is some data that we have today. The table basically shows what are the today in some of the vendors, what are the buffer sizes that are available, and then we have measured the number of flows and the buffer size that we need for different RTTs. So if you take an example of, say, 10,000 flows.
So sorry, I just need to stop you here, because you are aware that this information cannot be Microsoft confidential. So I know that you are using a backup. Yeah. So you need to provide us a kind of a fixed presentation with without company.
Oh, okay. Could you move on to the next?
Yeah.
I mean, I took out all the confidential information, but I didn't take out the Microsoft
Right.
confidential. But you can move on to the next slide.
You actually have also IETF91 Honolulu.
Oh, that's
good memories.
Yes. Okay, so let's focus on this slide. So this is the RTTs that I took from our SWAN data. For those who are familiar with what a SWAN data is, it's what is Google's B2 network, which is basically a smaller network that is used to transfer geo-replication traffic just for index serving stuff, which suffers from a lot of elephant and scavenger flows. It's not the one that goes over our primary 8075 ASN. It's the smaller network. It's got a fewer routers, and I've taken the least, the highest, and the average latency that these links went through. And let's focus on the middle one, which is the 60 milliseconds latency. You can see that I've gotten the data for 25, 10, and 100 gigabits per port. The straight lines are basically the bandwidth that we have per port. The 5 megabits actually per port, which is very high. And then the blue and the gray lines below are the smaller smaller buffer sizes, which are like 0.5 and 0.67 per port. And so you can see that you have to have like a ridiculously high number of flows for you to justify the small buffer sizes. And so Appenzeller's theory in this case does not really hold true. And so this slide basically graph shows on that you need to have more data to correlate the number of flows, the packet discards, the latencies, and the buffer sizes. Next slide, please. So to conclude, this is, it still is very relevant. It's very important to Microsoft, and speaking to certain other operators, I know that it's very important to them, but there is no collaborative work done on this. We are doing some collaborative work with a few other operators, and we'll be presenting that study in a workshop in fall at Stanford. And we'll be bringing that back to the IETF, but this is something that we started at the IETF, and we wanted to share that. So we do need to mine the empirical data and a way to standardize these results.
Thanks.
This is West George. You said you needed a way to get information about the reasons for the discards.
Mm-hmm.
Do you have any proposal on how you would get that, or is that where you're working with operators to try and mine that?
So, so what we have is what we use, and I can speak as to what we use internally. We use IPFix, we use SFlow, we use SNMP, but they're all different and they're all scattered, and we don't have a single way to do it. And from a vendor perspective, each one has a different thing. Some of them have smart buffers, some of them have some kind of flow analyzer stuff on their, how can I say this without breaking in any, they have different kinds of methods too, but there is nothing that is standardized. And we don't want to tell the vendors what to do, but we want to put the problem out there and seek information on that.
Okay. I think you probably are not going to get a particularly good cross-section of data out of things like flow, since typically it's sampled.
Yes.
But was going to relate one thing that we've seen. I work for Time Warner Cable, so we've been poking at some of this stuff in our own network. And one of the things that we found with one of our primary router vendors is that while on paper they may have a certain buffer size, the execution of how that's actually carved up is much, much lower, to the point of being almost zero. Basically, because they typically take into account the percentage of bandwidth that might be allocated in any QoS policies, and identify it as basically an offered rate. Depending on how you have QoS policies available, they're dividing the line rate of the interface by the offered rate, and if you don't have an offered rate defined, it's basically 1% because you can't divide by 0.
Yeah.
And so what you end up with is these buffers that roughly translate into a millisecond or two, which means that any amount of bursty traffic of more than a fairly small window is going to end up with pretty significant packet loss that is otherwise unexplainable.
Yeah.
So that might be an avenue for you to look at when you're working with the different
so
router
we
vendors.
definitely look at that, because no matter how big the buffer size is, TCP will fill it up. So that's not the whole point. The point is to have the minimum buffer size and at the same time have a good link utilization.
Right, but that's exactly what I'm saying. Is this basically goes the other direction.
So I need to ask you to take this discussion offline, and there are two good reasons. One of them is that we run out of time. We have like 2 minutes until the last 10 minutes. Second, I'm not sure. No, you can ask your question and make your points. Okay. Second, I'm not sure how much this is within scope. I believe that what is within scope is a general method of bringing data mining and empirical data using LMAP. It's less the routing and routing buffering specific metrics, which I believe that are not in scope here. So it's a method of transport and of collaborative work for data mining gathering. That's something, and I believe that what you need to do in the next iteration of the internet draft is kind of try to abstractize and kind of be more specific about what you need from LMAP, or what you suggest to do in LMAP.
Yeah, so I think I agree, because I think the metrics definition should be taken away from LMAP. But what about the information model and a kind of a framework?
Probably not.
That would belong.
Probably that could belong to the extent that they don't refer to the metrics.
Only for what?
They could. What needs to be left is what is actually dealing with the transport and the method of getting the data and assuring that collaboration actually, because it's a collaborative use case.
Yes.
Yeah. Please.
Matt Mathis, Google. I think you've sort of turned the problem around, because the problem that the ISPs care about is actually an optimization problem. How do you decide to spend money on buffer memory versus capacity? Because there's a trade-off there from the ISP standpoint. And how do you meet a certain performance set point for the users or whatever by balancing how heavily you load your network against how much you spend on building it up? And that problem is extremely valuable, of course, to ISPs to have better understanding on it. And focusing on that aspect of it, which is not using protocols to observe the network, but using protocols to give telemetry to help the owner of the network optimize the network.
Yeah, so that was what my first slide spoke about. How do we, like you said, the board design, if I put more packet, I'm going to lose capacity and vice versa. So.
But the real question is helping to steer investment.
Helping what?
To steer investment.
Right. Driving down dollars per gigabits, yeah.
Okay, so two things, please. So one is send us an updated information, cleaned up, and I don't know, try to maybe generate the PDF by your means and send us directly the PDF. So because you are using a version of Microsoft stuff that is too advanced for us, and make sure that you set also the footer of the slides right. And thank you. And the next version, so please focus on kind of the LMAP relevant stuff.
Yes, I think we will clear that.
Thank you. Okay, last is Motoyuki. This also is a revisiting of the informational draft about LMAP internet measurement.
Hello, my name is Motoyuki. Nice to meet you. And I will talk about our draft briefly, and I will talk about my proposal of extension for end-to-end to the LMAP working group. I will talk about the first one, our motivation. We are measuring the network performance for end-to-end data since 2011 by using original measurement system. We would like to share our current status and Japanese status and our experience to the LMAP working group. And the second one is to propose extension for end-to-end to the LMAP working group. We need some more. We need extension for end-to-end measurements. So we would like to discuss some options for the LMAP working group. Okay, next slide, please. I will talk about the background, our background, why we are measuring for end-to-end. We have three backgrounds. First one is to improve customer satisfaction and network operation. This is our goal, and the monitoring actual performance is important for ISP. And the second one is to understand student behavior. So student traffic volume is increasing, and also senior distributing some internet contents from multiple areas. So we have to understand the behavior of the CDN. And the next, and the third one is to publish evaluation report of ISP. Content service provider such as Google and Sandvine publish the original report from on the web, and we would like to compare each report, and we would like to compete the measurements data. It is a background, and also the government in Japan try to standardize the measurement of the mobile network performance. They are investigating the appropriate place, the number of probes, and times for mobile measurements. And also they are developing original measurement tools, and they are going to publish the analysis result using box plot analysis. Okay, next slide. Okay, let me show you our internet measurement system. The details are described in the second version draft. It may be similar to LMAP framework, but however, our measurement system is different from some points. We use Friendly as a report protocol. Friendly is open source middleware software, and measurement agents can get measurement table from controller, such as measurement schedule table, measurement ISP table. So measurement agents changes the ISP account automatically, and also measurements start measuring to target content. And we focus on end-to-end measurement. So measurement pair is a public server, such as Akamai server, YouTube server. And also we can get any kinds of ISP and area. So ISP area and destination. So we are analyzing the measurement data to improve our ISP operation and discover useful information on the internet. Okay, next slide. Okay, I will talk about LMAP extension for end-to-end measurement. I'm thinking about 3 points. First one is to extend the measurement pair. So we would like to focus on an end-to-end measurement. So in the LMAP frame, we would like the measurement pair in other ISP or in other CSP. So currently, LMAP model, I feel like measurement agent and measurement pair in the same AS. And measurement next extension, we would like to think about
problem. So please make your comments in the context of comments as comments to the RESTCONF protocol.
Sure, no problem. Yeah.
Thank you. And thanks everybody for coming and contributing.
Aren't you early? We get set up. The wire is on this side. It's also on the other. Baby's here? Yeah.